Welcome back. This is Mwalimu Arnold Sekago, and this tutorial is on structure and bonding. So we continue with our series of responses on the items that I had previously shared here. So earlier on, I said that for different kinds of substances, we shall use the following analogy. We shall use the following following to recall the properties that are always examinable. So we shall comment on the state, solubility, structure, melting point, conduction. So M stands for melting point. Kindly take note of that. M is for melting point, C is for conduction, then D is for density. Alternatively, one can use science solves structures money cannot do. Science for state solves for structure for structure, man for melting point, then it cannot conduction do for density. Now let us take an example. Our first compound, our first substance of consideration was the potassium chloride. Potassium chloride, that was our first substance according to the item. So we start with state. Potassium chloride is an ionic compound. To think about a basic example of ionic compounds, one can take sodium chloride. Sodium chloride, the usual common salt. The usual common salt is a solid at room temperature because it is an ionic compound. So similarly, potassium chloride is an ionic compound. Therefore, what is the state? Its state exists as a crystalline solid at room temperature. Now recall that here they tasked us to explain, and I remember emphasizing that the item required us to explain, not state. Those two statements are different. List it down, explain, describe, outline. So explain, you have to explain the property. If you say that it exists as a crystalline solid at room temperature, what is the reason for the giant ionic structure to exist as a solid at room temperature? So it exists as a solid at room temperature. Why? Because of its rigid 3D three-dimensional structure with ionic bonds. Now, this is the structure. Earlier on, previously, I illustrated that, and if you are watching this video for the first time, I'll refer you to the previous videos. So you see, this is the giant ionic structure. It is made up of, are you seeing those things in green? I think, is that color green? Those are negative ions. So it is made up of negative ions. Then those in black are positive ions. Now, this is an example of sodium chloride. So sodium chloride is made up of, it is made up of sodium ions and chloride ions joined together by ionic bond. So this is the three-dimensional structure. Why are we calling it three-dimensional structure? Because it has a length, it has a width, it has a height. Those are three dimensions: length, width, and height. That is three dimension. So I take this as a solid because this structure is rigid. Those lines you are seeing, the lines joining ions, you know what we call them? Their names are ionic bonds. The bonds that link ions together. Therefore, for this case, for potassium chloride, we shall say that it exists as a crystalline solid at room temperature due to its rigid 3D structure with ionic bonds. That is for state, the first statement. Science for state. Then I've told you, you relate with common salt. Common salt is soluble in water. So also here we are going to say that potassium chloride, is soluble in water and other polar solvents. Why? It is soluble in water because water molecules break apart its structure. So the water molecules can separate those ions that make up potassium chloride. So that is for solubility. You state soluble in water. Why? Because water can break down the ion that make up potassium chloride, or because water molecules can break apart its structure. Then what else? The structure. The structure, we have seen that it has a giant ionic structure. It has a giant ionic structure in which potassium and chloride ions are held together by ionic bonds. Then the other property is M, melting point. Melting point, ionic compounds have high melting and boiling points. So potassium chloride has a high melting and boiling point. Why? Because of strong ionic bonds. Those bonds between positively charged potassium ions and chloride ions are very strong. You have an attraction between oppositely charged ions. So that attraction should be very strong. In this case, we say that they have high melting and boiling point due to presence of strong ionic bonds that require much heat to break. Then another property that is for C, conduction. We are going to say that for conduction, I don't know why I'm disturbed by this screen. It conducts electricity in molten and solution form. Why does it conduct electricity in molten and solution form? Anything to conduct electricity, it must be made up of ions or electrons. It must be made up of charged particles. Charged particles, those are ions. So here, potassium chloride is not made up of electrons. However, in molten and solution form, that is in water, if you dissolve it in water, it forms, or it splits to give potassium and chloride ions. Therefore, those charged particles are the ones that conduct electricity. I'm going to say that conducts electricity in molten and solution form because of presence of potassium and chloride ions that can move under influence of an electric field. That's why it conducts electricity, due to presence of those charged. Then what else? We are left with the D, density. Potassium chloride has a, I think I have to change this thing. Because it's disturbing me. So potassium chloride for D. I don't know why. It has a high density. So D, it has a high density. Why? The density is high due to the tightly packed 3D dimension structure. So those are the general properties of ionic compounds. One can relate these properties to any other ionic compound of interest. So what did the item require? The item required properties of potassium chloride, properties of any one. The item was having potassium chloride, it was having methane gas, it was having graphite, it was having which other one? Potassium chloride, methane gas, graphite, and I forgot the other one. Potassium chloride, aluminium. There was also aluminium. Yeah, so these are potassium chloride. These are the properties.